Scientists at AgResearch in along with Otago University, have a long association with New Zealand's deer industry. Currently a large project funded by industry, AgResearch and Landcorp, is building on earlier work on productivity, as well as better understanding natural resistance to parasites.
The Hitting Targets project is a multitude of different focuses on animal productivity and profitability, but by and large it's themed around certain areas where we can make the best bang for buck, so to speak, for deer. And one of those areas is genetics. And we focus strongly on genetics because we've got an animal that's only 40 years into domestication, so there's a lot of opportunities out there to improve the genetics. The DPT is short for the deer progeny test, so that's been our flagstaff genetics project for the last few years. One of the key objectives was to use the deer progeny test, or the DPT, to allow for improved linkage between farms with their sires. So it's quite important for farmers who buy sires to understand if they look at the breeding values for stags on one farm, they reflect what's happening on another farm, rather than just each farm doing their own thing.
Right, so we're bleeding in cattle sampling today?
Yep. Just scan them first. The deer industry has a national genetics database, and that's called Deer Select. It's developed on the Sheep Improvement Limited database and analytical system. So, we haven't invented something new, but we've been able to modify something existing. And there are quite a large number of breeders or stud breeders that actually put data onto Deer Select, and we use that to calculate the breeding values of the stags and the hinds for particular traits. At the moment, it's mostly growth traits, but as a result of the deer progeny test and other work that's carrying on now, we'll have a wider range of traits available to them other than just growth. For instance, farmers often talk about temperament or the behaviour of their deer when they're, with humans. So what we've been looking at are other opportunities like that. For example, one of the things we're focused on at the moment is around disease management. How can we use genetics to improve our ability to manage disease in deer herds? Ultimately, what we would like to see is that the industry adopts what we call indices or indexes, where you combine a number of traits and you develop an economic index. So you're actually developing an animal across a range of traits rather than just focusing on one trait. There's a couple of things we're doing today. One is to collect a saliva sample, and that's used to assess the amount of KALA antibody in the saliva. And that to us is a very good indicator that animals are mounting an immune response to ingesting worms. And that potentially has a lot of utility in the deer industry for being able to select for animals that can be resistant to worm challenge. And the other thing we're doing, and it's related to it in a way, is the blood sample. And that's taken to look at various biomarkers, we call them, for immune function as well. So the work is really focused on, can we use genetics, produce an animal that can perform well in natural farm environment in terms of being able to deal with disease challenge and still be productive.
Our particular area of interest is animal health and disease. So the particular aspect we're concerned about is really how can we better understand and manage diseases. The two diseases we are focusing on is Johne's disease, which is the chronic enteric disease, and parasitic diseases. And both of those obviously have become part of the deer progeny test program as another example of a production trait. I believe parasitism is the most important production-limiting disease that affects not only deer, but also other livestock breeds like sheep and cattle. It's a very, very expensive disease. Parasites have evolved uniquely, not to kill their host, but to coexist with their host. So they're the ultimate pathogen, really. And they're very widespread, and they cause massive production-limiting effects at the most important phase of an animal's productive life, which is its juvenile growth. We will be able to assess the predictability of the markers we're using probably within a year, but then we need to confirm that concept downstream, and that will require at least 2-3 year studies.
Certainly, in terms of genetic progress, the industry has been very strongly focused on growth rate for venison production and antler size for antler production. But now we're starting to look much wider than just single trait selection. There are dangers in that, of course. So we're more interested now in progressing the industry down pathways that look more at things like the actual product itself, so the venison. So we've done a lot of work with the deer progeny test on the carcass and the genetics of the venison quality traits. And if nothing else, it's to show us that as we use genetics to progress our animals, we don't denigrate the product, but the upside is we may actually be able to improve the product through genetics. There's no doubt about it that New Zealand is the world's sort of major deer farming nation, and we're sort of kind of lucky to have a non-native animal that was once a pest and now can be utilised for farming. But I'd have to say that the success of deer farming rides on the back of the animal itself. It's a very adaptable animal, much more adaptable than I would have ever given it credit for years ago. And there are probably many deer species that just wouldn't succeed in that farm environment because they don't have that level of adaptability. But, we're still a young industry, 40 years to go from live capture of wild animals to the type of situation we're in now where we can comfortably yard the animals and work with them and manage their genetics is quite a major feat in my opinion.
This program was made with funding from New Zealand On Air.